Hello, we are continuing talking about light. I'm on page 242 in your textbook. Make sure you have a pencil handy so you can write in some of these words on your textbook. It's going to be so great when you turn them in. I'll be able to see all of the work that you've written on your textbooks. That'll be fantastic. So we talked about light. Light travels in waves. There is transparent, translucent, and opaque materials that can either let light pass through, let some light pass through, or not let no light pass through. Um, Light can move through empty space, which is why we see sun and we have heat and light as well. And not all light waves can we see. We can see visible light, but there are lights that travel, there is light energy that travels with shorter wavelengths and longer wavelengths that we are not able to see, but still is there nonetheless. Today we're going to be talking about how light changes direction in 3 different ways, and then we're finished with the section. So, are you on page 242? So there are 3 ways that light can change direction. When light hits an object, some things might happen. The first thing that can happen is maybe light is reflected. So light is moving in a straight line, but then goes off in a different direction. And it's still so straight. It's not wonky. It has an angle of reflection that it goes with. As you can see, the same angle it came towards is the same angle it reflected off of. And so reflection is light bouncing off of an object. A big example of that is a mirror. Refraction is where light is bent. We use these in some telescopes. Refraction is when light bends. So notice light bounces in reflection. In refraction, light bends. If I have a lens that is concave or convex, I am causing the light to bend as it comes through or refract. Now, we see this a lot with water stops as well. It says, for example, light bends when it goes from water to air. And so that's why when I look underwater, my legs appear shorter than they actually are. Because light travels through different materials and is bent as it is doing that. Microscopes, cameras, prescription glasses, they all have lenses, which if you have glasses, if you look at your lenses, they are curved. Like Mrs. Bulwark's glasses lenses are curved a little bit, bending light. Identify which of the pictures below shows reflection, which shows refraction. Label the pictures. So I've already kind of spoiled it, but this turtle is refraction because we can see the light being bent as it looks like the turtle is this way, but then the turtle is this way. It's not 2 turtles, it's 1 turtle with refraction. This guy with the sunglasses, is this refraction or reflection? It is reflection. I can see what he is staring at through his sunglasses. The light is being bounced back. All right, good. We have one more way light can go through something, and that is dispersion. So different colors bend or refract at different angles. Since white light is a mixture of colors, when I pass it through something, sometimes the colors can separate or disperse, forming rainbows. So rain, you see a rainbow after rain, but in order for you to actually have a rainbow, the rain droplets have to fall at a certain angle. And so for the light to be able to refract or bend off of the rain droplets. And if you've seen a prism before, it's dispersing the white light into different colored lights. We look at question 6. It says identify, look at the picture to the left. What colors refract more than green and what colors refract less? So, Blue. Blue refracts more than green. It bends more than green. We can see that because it has a harsher angle with the original white light. Red and yellow refract less, as their line is more something that we consider straight. It refracts less than green. So blue refracts more, red and yellow refract less. Okay, got it? Let's look at questions 7 and 8. 7, it says, infer. Things under a microscope often look like they have rainbow colors around. Why do you think this happens? Well, microscopes have lenses that refract light or bend light. Refraction would separate light into different colors. So when white light enters something, it can be dispersed through refraction and create different colored light. So once again, microscopes have lenses that refract light. Refraction separates light into its colors. And then explain, why do you think most lampshades are made of translucent materials instead of transparent materials? Definitely not opaque, because then we can't see light through it. Direct light from a light bulb can be too bright. So we want light, but we don't want bright, intense light that'll hurt our eyes. So direct light from a light bulb can be too bright. All right, and that is the end of section 3 for chapter 6. You have your homework on Wednesday, and then we're going to review for your test next week on Thursday and Friday. Have a great day!